Hey, Year 12! I don't know how many of you guys are going to be here today because I know that the school's asking us to do post work on the classroom rather than doing a live feed, but I'm going to be doing a live feed from now on. All of our lessons, or at least as many of them as I can, will be live on YouTube, and you'll be able to watch. I'm just trying to get myself all set up so that I'm not going to be using up all my bandwidth, etc. I've got my chat there available. When you arrive, can you please just write on the chat saying that you're there, so it does my register for me, so it'll log who's in the classroom with me. Okay, so today we're going to be covering alcohols. This is actually lesson 2 in the alcohol series. We've already covered primary, secondary, and tertiary. Today we're going to be continuing looking at the oxidation of alcohols, and just making sure that we can write the equations for it, draw the products, and recognize the equipment setup. I'll do my best on finding images for the equipment setup. I'm also going to be popping into school at some stage in order to do the practicals and be able to videotape them, and I'll post them onto YouTube as well. I'll talk you through the pros and cons that each practical has, and look through the exam style questions then afterwards on a live webinar. Okay, so I'm going to share my screen. I'm going to drop into, there we go, and I'm then going to make that one disappear. There we go. I'm going to do this. So, okay, so this is what I'm working on today. This is just this looking at your specification. So I'm just going to check that my pen is all working. Yep, there we go. It's going to be interesting to see how my laptop copes with all of these webinars. I'll do the very best that I can. I'm also going to crank up the speed of that just a little bit. Okay, so we have already looked at step number 1 in our first lesson of alcohols. I'm going to make that a little bit thicker. We've already looked at their structures, drawing them displayed, drawing them skeletal, and we've already looked at this idea of primary, secondary, and tertiary. So what I'm going to quickly do is I'm going to try and make the webinars about 45 minutes. That's my target. But I'm going to try and also make them a little bit more interactive by giving you guys some questions. So I can give you question number 1. Now, what I'm going to do is I'm going to write the question down, and then what I'm going to do is I'm then going to ask you guys to pause the YouTube video, have a go at it, and then unpause it to see what the answer that I'm drawing. So the question would be, draw displayed formulae of a tertiary alcohol with 6 carbons, 2 branches. Okay, so now that you've got the question, you can pause the video now and then have a go at drawing that one, and you can then come back to me in however long it takes you to complete the question, and then you can see what my answer is. So pause now. So the answer, and it's a clever process this when they give these kind of puzzle-like questions. What they're doing is they're looking to see how you go about building something. So in this case, the place to start is your tertiary alcohol group. So we've got to immediately draw out this structure. And of course, it's just displayed, so I have to show all my bonds. And then I've got to realize that my alcohol group must go here. And then you've got to realize that I've got 6 carbons and 4 have already been taken up, and I need 2 branches. So I'm then going to add on another carbon there to add the 5th. But then I now have only 1 place where I can put my other branch. Yeah, you can't put it here. Students often like to put it up there. Yeah, that's not correct. The reason being is that becomes your longest chain, and there's only a single branch. Can't be done there. So that's not okay. So you can't put it on the end. Students often like to do this. That, of course, is not a branch, still part of the longest chain. Oh, don't know why that suddenly appeared. There you go. So that can't be done either. Remember that bends are not the same as branches. Branches must be within the middle of the chain. So there's only 1 place for us to put it, and that's going to be here. So now, of course, we're going to show all of our hydrogens, show all of our sticks as good practice, and counting them all on. Yeah, and then I'm going to put H's all over those. I'm not going to bother in the practice to save myself a bit of time. And then, of course, at that point, I'm going to ask you the second question, which you can then, of course, pause on. So the question number 2 is going to be, name it. Name the alcohol. It's nice the fact that I can give you such a question, tertiary alcohol, 6 carbons, 2 branches, and there's only one choice. There's only one structure that you're allowed to draw. So I've given you the name, pause the video. Once you've paused the video, I still have no watchers, and I'm worried that that's going to be an issue, but we will see. Okay, so answer. So step 1, find your longest chain. So it's going to be based on a bute. So this is a bute. Next, is it an ane or an ene? Well, they're all carbon-carbon single bonds in the main chain. In fact, if it was a double bond anywhere else, for example, here and here, it would have to be part of the main chain anyway. So it's going to be a butane. Butan. I'm going to put the E on, but I'm going to put a dot on it, knowing that I'm probably going to need to remove it if there's a suffix tacked onto the end of it. Next thing, identify all my additions, my add groups. So I've got first addition group there. So this is a dimethyl. This is a dimethyl, and it gains numbers now. So we're going to number it from this direction. We're not going to number it from this. We're going to number it from this way, not that way. No. And the reason why, of course, is because the alcohol is the most important group, and I want to make that as low as possible. So if I go in the not direction, it then becomes a 3, whereas if I go in the actual direction, it becomes a 2. So this is going to be a 2,3 dimethyl, and then I've got a 2-ol group at the end of it. So then I can add all of these guys together. So I've got 2,3 dimethyl, bute, and the E disappears, 2-ol. Tertiary alcohol, 2 branches. Cool. Okay, so going straight on to the next bit. So it's just a bit of a reminder. What I'm trying to do is I'm trying to do a little bit of revision on this whole idea of primary, secondary, and tertiary, recognizing that a tertiary alcohol has got the 3 carbons. The most important carbon in any alcohol group is that guy, the one with the OH on it, and this is joined to 3 other carbons, making sure that we understand that that's going to be up there's the 3 other carbons, so it's going to therefore be a tertiary. I won't give you another question because I prefer to just move on with content, but we can add more questions in as we go. Okay, so the reactions of alcohols. Now, the first thing that I want to do is I've already started the process of talking about their oxidation. Now, if you notice on this particular list, I haven't, the oxidation actually isn't included on this. These are kind of the standout reactions that they tend to ask, but actually not asked as heavily. And if I actually go to the specification, which I actually have on hand, the oxidation of alcohols is slightly lower down. There you go. It's 0.1018. So I'll actually snip that and I'll add it into my notes. I'll snip it and add it in because actually that's really what I'm focusing on today. Actually, I might go a little bit further than that because it also has preparation in terms of reflux or solvent extraction. I'll stick with that bit for now. Giving the positive test. I like it, so let's go new. I'll cut this little section here and put it into the notes. So, I've done it again. Not doing this particularly well today. Let's try that one more time. There we go. And go edit, copy, and then I can lob that into here. See if I can put it in there. If I actually just do this, paste. So, okay, so here are the key bits that I'm going to be focusing on today. I'm just going to move that actually down to here, I think. There we go, so I can get to kind of focus on this. Okay, so understanding that potassium dichromate in dilute sulfuric acid can oxidize primary alcohols and produce aldehydes. Test for the aldehyde group that is formed. Primary alcohols can be oxidized, of course, to carboxylic acids. So, by the way, nice to do the GCSE reminder. Because at GCSE, we get to do, so let's just do oxidation. So subtitle, oxidation of alcohols. Now from GCSE, we learned at GCSE, we learned that alcohols such as ethanol, and they did focus specifically on ethanol. It's one of their key things that they were constantly doing. It was basing it around key molecules. They weren't looking to make it massively complicated for everybody. They wanted to focus on one particular molecule. So they're focusing on ethanol. And you learned that you could oxidize it. You even learned the oxidizing agent. We could oxidize it to a carboxylic acid and ethanoic acid. I'm actually going to put in the real one there because it's actually better for me to do so at A level. But you realize we could oxidize it to ethanoic acid. Now, of course, IGCSE is laying the foundations for A level. They're not. Now I've got 3 watchers, which is great. If you guys can post your names on the chat so I know who's here, guys, as the register, that would be appreciated. So oxidization of alcohol, so at IGCSE, ethanol to ethanoic acid. And then things evolve then at A level because we learn that there's much more detail on here. So now we need to talk about the oxidation of alcohols, but we now need to add in brackets, primary, secondary, tertiary. We need to add in this extra bit because there's now separations between the 2 of them. So with a primary alcohol, such as ethanol, so for primary alcohols, we can oxidize it. And now I'm going to start using the symbols that you need to know for A level. So this O here represents an oxidizing agent. And the example, of course, and I'll put it down here, the example of an oxidizing agent is potassium dichromate. I've got people messaging, which may mean I've got an issue with the webinar. Potassium dichromate. Let's see if I've got people messaging me. No. Oh, no, that's okay. Potassium dichromate, but that's not enough. You need to also say with dilute sulfuric acid, dilute H2SO4. You can't just say the actual agent itself is that one. So there is actually 2 levels of questions here. They often say, give the oxidizing agent, and the answer is to that one is potassium dichromate. But if they say give the reagents for the process, for the reaction, you have to give both. So it's a tricky one, that one. Primary alcohols get oxidized to aldehydes. And then go through a second oxidation reaction. And become a carboxylic acid. So they actually have a 2-step process. Now, you didn't learn that at GCSE. You didn't learn about the family of aldehydes at GCSE. So this is new to you at A level. What that means is we're going to get several equations for this. So if we do, let's do ethanol. Now, I'm going to make a point in this particular lesson of doing this C2H5OH. I hate that. That is a horrible, horrible mismatch of molecular formula and structural formula. I don't like it. You should avoid this. You should delete this entirely. You get taught it at IGCSE and I hate it. I have to delete it. You're never going to use that. What you're going to be using is you're going to be constantly using structural. Now, I know that this is the hardest formula for A-level students to wrap your head around. Just remember that this translates directly from a displayed. It just translates out of it. And you're reading them from left to right. So you can see the CH3 at the original. So there's the CH3 being done there, and then the CH2 being here, and the OH. Realizing that the C's are coming first before the H's. But it is a tricky process. And I am aware that students find it challenging. So we're now going to oxidize this oxidizing agent, and we're going to produce the aldehyde in the first step. I'm going to put those in. I'm going to produce the aldehyde, and of course the aldehyde ending, we know that OH is ol, and the way I always remember aldehydes is cho. I still have nobody having mentioned anything on the chat, which is rather frustrating. I don't know whether or not that's... Say hi, folks. Please say hi on the chat. I would really appreciate it. So ethanol is oxidized to ethanol, and the aldehydes end in cho, CH3CHO. There's the aldehyde ending in structural. It's just nice to start emphasizing those key things to help you remember. Cho is a great one for aldehydes, and Ku for carboxylic acids. We can then oxidize this again We can oxidize this again. Oh, got to be careful, because actually I'm about to make a mistake, aren't I? That reaction there I need to do is a separate one. I'll actually show the product of this in terms of displayed. Ah, there we go. Ria, here. Fear not, well done. Kayun was here before Ria. Jasmine, hi. Great job. Thanks, guys, for appearing. Really appreciate it. So the aldehyde, it's nice to draw the displayed and the structural. We need, of course, focus on being able to do that one. That one, of course, is the harder version. But let's just put the oxidizing agent as well. It's nice to draw it. There is also going to be a byproduct, and that byproduct is water. Just to explain to you what's happening, the O, the oxidizing agent, which I'm going to draw in orange, which is really cool. I'm going to highlight that in orange. The reason being is potassium dichromate is orange. K2Cr2O7. It is a true orange compound. One of my favorites. It's like highlighter orange. It's rather pretty. And what that's doing is it's going to take him and him. And it's going to form water as a byproduct, and it becomes green. It becomes green at the end. By the way, it's not the water, by the way, that actually becomes green. The reason why it becomes green is because the chromium in potassium dichromate here is in a +6 oxidation state, which makes it orange in that particular compound. And at the end of it, it becomes chromium 3+. And I'm not going to draw out the structure of all these things because it's only going to complicate matters. But actually, that's actually the reason for the whole thing turning green at the end. Start off with orange chromium, potassium dichromate or chromate 6, dichromate 6, and chromium 3+ at the end being green. So, and they do often ask this, give the reason for the color change, give the species at the end, and all we have to say is chromium 3+. So quite nice that. But it doesn't get included in the equation. Now that's one of the things that fascinates students. They often, I'm just going to put that rather than underneath them. I think they actually probably would prefer having their own little nota bene box. Nota bene, I prefer that. So in the nota bene, I can say K2Cr2O7. And the dichromate, the chromium, of course, is in a +6, and that's what gives it its orange color. That there is orange. And then that becomes chromium 3+, which is green. And that's all you need to know. That's it. You don't need to know anything else. And you'll notice the equation balances. The oxidizing agent takes the H's and becomes water. Cool. Okay, now there's a second reaction. We realize that aldehydes now can oxidize again. And they can oxidize, I don't know why it's doing that, oxidize again to carboxylic acids. This is so that in GCSE, they simply skip the middleman. That's all they're doing. And I kind of understand why. They're trying to introduce families. They're trying to introduce you to reactions without making it overly complicated, which I do understand. And you'll notice there's no byproduct for this particular step. The reason being is the oxidizing agent simply inserts itself into that particular position there to become a carboxylic acid. In reality, it's much more complicated than this, but you don't need to worry about the mechanism. There's none that you need. That is all you need. You can now, of course, create, these are the two separate equations, the process. Yeah, this is what we've done is we're looking at the equations that go along with this process here. That's what we're focusing on. We're splitting this up into its two processes, and we can see the two reactions. We can, of course, create an overall by combining them. If you want, we can combine these. We know that those are going to cancel. And so we're going to end up with 2 oxidized. So the overall equation for producing a carboxylic acid, and again, they do ask it, CH3COCH2OH plus 2 oxidizing agents, which because they combine because they're on the same side of the equation. And I'm going to end up with the ethanol disappears, it becomes ethanoic acid, and I do get a byproduct of water. So there's the overall equation. There we go. I don't know why I decided to draw it out. I'm mixing equations there. Shouldn't do it. It's really bad habit. CH3, I guess I'm trying to show the structure whilst, let's see if I can zoom in a bit. But I shouldn't be. I should be emphasizing the difficulty of structural equations and structural formulae. Oh, Sherlyn, Emma, Nikita, hi. Great to have you. Thanks for coming. So this is the overall equation. Back to our notes, really, to realize that there are 2, and I'm going to show you some exam questions in a minute. So overall equation is there. There we go. Okay, so now that we've seen primary alcohols, what we now need to do is look at secondaries. So secondary alcohols, by the way, often just notated as this, secondary alcohols. So alcohols, we'll look at propan-2-ol is a classic, of course. It's a nice common one. Propan-2-ol, there we go. Secondary alcohol. Got messages appearing all. Sorry, I'm late, Dana. Good to see you. Thanks for coming. Secondary alcohol, carbon with the alcohol group attached. And of course, it has 2 carbons attached to it. So it's secondary. Now, of course, we're going to oxidize this. Let's translate that out. Oh, good job, Nikita. So let's translate out to structural, CH3. CH, the OH becomes a branch, bracket branch, and then CH3 again. We're now going to oxidize this. So I'm going to do both the displayed equation plus the structural. And in this case, a secondary alcohol only has 1 step. It forms a ketone and stops. I'm actually going to orientate this to show you why this is. Formula CH3COCH3. There we go. No, oh, there is a byproduct of water, of course. Let's try and draw this to make it a bit easier to understand. What's happening is the alcohol group there and the H on that C. I'm just going to do it like this just to emphasize that those H's aren't doing anything. The H that matters is this one. The OH group, yeah, and the H are what make the difference here, because if I now add an oxidizing agent, such as potassium dichromate, which is orange, it's going to steal the H's here. That's what's happening. And so I'm going to end up with the ketone. Notice that it's only the H. It is only the H on the carbon with the OH group. This is kind of important, really, because it helps you understand why tertiaries resist oxidation. And then, of course, there's our ketone being formed in the end, CH3, CH3. I shouldn't do that. I don't like those equations. I just wanted to show you the H is not involved, the ones on the CH3 group. I don't really like them. I much prefer my previous diagram. If you're going to draw it displayed, draw it displayed. Don't try and mix. But it's just me trying to show an understanding. So what about tertiary alcohols? Tertiary alcohols have got a problem. The carbon with the OH group, what you'll notice, has no H's on it. The only H's available are on the C's next door. So the carbon with the OH group has no H's attached. Unlike this guy who had a H attached to that C, this now has none. What that means is it's going to resist oxidation. If I add an oxidizing agent to this, such as potassium dichromate, it will do absolutely nothing. No reaction will be seen. Now, this now drops into it being, I don't know who the mean beans is. Who's the mean beans? Come on, guys. I love that everyone else has given me a normal name except for mean beans. Oh, my goodness. So tertiary alcohols resist oxidation. Now, this gives us a lovely little addition to our notes, which is this now can be used as a type of chemical test. So another nota bene, chemical test for alcohols. Test for, I'm going to zoom out a bit, there we go, for alcohol. Chemical test for alcohol. So number 1, top test, potassium dichromate. I'm actually going to say, by the way, I'm actually going to add in, you have to actually say acidified. Now, I still don't like that. Acidified K2Cr2O7 saves me writing the words. Yeah, the acidified. Now, there's a problem with this. And this is actually it's Ivan. Hi, Ivan. Thanks for coming. So acidified, of course, just simply means that there must be acid present. Students often wonder why the acid needs to be present. The reason being comes from the redox equation. Just to quickly do a bit of recap on redox, we know that we've got Cr2O7 2-. I'm just getting rid of, you recognize that I'm removing the potassium because it's going to be a spectator ion. And I'm going to get this now down to chromium 3+. This is the color change. Here's the orange dichromate, and here's the green chromium 6. Right, okay, folks. So here's a question for you. I'd like you to pause the video at this stage, and can you now complete the equation? Can you balance it, please? I'm going to give a helping hand just to remind you guys to weigh your equation, yeah? To weigh them. Of course, I'll be using this now in fact, what I'll actually do is I'll put them away down here because there are going to be students watching this. Would it be okay if you shared us these notes during the online learning period? Sherlyn, of course I can. I'm happy for you to have access to my notes. In fact, I think I already shared you my OneNote files as well, of course. But yeah, absolutely I can. Just ask me and I'll add you to my share. In fact, I can do it now, Sherlyn. I can do it now. So email, and I'll add Sherlyn here, I think. I think it might come up. I don't know. Maybe it won't. Sherlyn, you'll have to give me your email address. I can't, it doesn't automatically give me it. Not unless I've already done it. I might have already done it. Have I not shared with you already? No, I don't think I have. Happy to add it anyway. So for those students who aren't in my class, I teach a process called weighing half equations. I don't actually call it weighing, I call it mo-weighing, otherwise known as kissing half equations, because it's a bit like the word moi. So I like to say kissing half equations. And what it stands for is the M stands for metal. Now, in reality, the metal is actually any atom that is not hydrogen, oxygen, or electrons. So the M stands for metal, the W stands for water, the A stands for acid, and the E stands for electrons. This is how you balance half equations, electrons. And just to show you what that looks like, so metal, of course, is anyone who's not hydrogen, and the reason why is water, H2O, is going to be providing us with oxygen. The acid, which is H+, provides us with hydrogen atoms. The electrons, of course, are providing us, they're balancing for charge. And the metals are everybody else. So in this case, it's providing us with chromium atoms. That's what's going to be happening here. But it could be anybody else who's not oxygen, hydrogen, or charge. But in this case, it's chromium. So let's now run this. So I've got, first step is metals. I do this in order. I kiss my half equation because I'm going to run my metal first. And I say 2 chromiums, 1 chromium. So that's out of sync. So I'm going to balance for it. Right, metal done. Next, water for oxygen. So I've got 7 oxygens here. I need to add 7 H2Os here. The reason why is each water gives me 1 oxygen. So now I've got my oxygens from my waters. Next, I'm now going to balance with acid. My acid is going to balance for the hydrogen ions. Could you share it with me as well? Of course I can, Ivan. That's going to provide me with my hydrogen ions and my hydrogen. So I now have 7. The trick is there. I've got 14. So there's 14 H pluses here. Right, now that I've got that, I'm just going to make all these lines disappear to clean it up a little bit. So now I've done my acid. Now I need to do my electrons for charge. Right, so what's the charge over here? So I have got plus 14 from the hydrogens, but I have minus 2 from the dichromate. Overall charge is plus 12. On this side, I have got plus 6 from the chromiums and 0 from the waters, so that's plus 6. Right, I can only ever add electrons, so I'm going to be adding electrons to make the match, bring somebody down. I'm going to add 6 electrons to that side, and there is my balanced half equation for what is causing the color change. It's quite nice, that. And the reason why I did this was it explains why it needs to be acidified. This tells us that I need lots of acid in order for this equation to go to completion. I've got to provide those H pluses for the redox equation to occur, for the oxidizing agent to be able to do it. Hence, it needs to be acidified. I don't like that, though. What I prefer, and what I would prefer you to learn, would be instead of acidified, I don't like it. There are questions which will stop you using it. The reagents are dilute H2SO4 and potassium dichromate. That is the answer to the, what are the reagents to oxidize alcohols for the chemical test? And it can be 1 mark, but you have to give both. Beware of it. Okay, so the chemical test is H2SO4 and potassium dichromate. And what I'm going to see is observation. Observation, I am going to see is that primary alcohols, orange to green, orange to green. Secondary alcohols, orange to green, O to G. But tertiary alcohols, no change. Remember to write no change and not no observation, because no observation means you've done it blindfolded. Not ideal. Yeah. I will share my notes with everybody, folks. Happy. Right, so it's just a nice test. By the way, there is a problem. Does everyone agree that there's an issue here? There's an issue with the fact that the tertiaries give no reaction, and the primary and secondary both go green, but it won't help me distinguish. So there's also a second test. So how do you test for an alcohol in general? So just a general alcohol test, general AL test, is to use sodium metal. General test, sodium metal. Now, sodium metal, of course, will react with the alcohols to F of S, just to give you the equation. So RCH2OH. I've got to show the carbon. I'm not going to try a general. I'm just going to give you one. Ethanol, because in reality, it's nicer to give you real ones than generals. I'm not a big fan of generals. Let's try and do this. There's ethanol going to react with sodium metal. And what I'm going to form is sodium ethoxide. You won't have to name this, year 12. You won't have to name it, but you may have to write an equation for it. So I make sodium ethoxide and hydrogen gas. And of course, balancing this is nice and easy. H2 with a half there. There we go. A levels, you can use halves, of course, which is nice. Do we need to know a mechanism for the potassium dichromate? No, you don't, Julian. Absolutely not. Just to explain why is potassium dichromate, you're going to laugh at this, Julian, looks like this. CR, this is what potassium dichromate looks like. It is a nightmare. Absolute nightmare it is. That's what potassium dichromate looks like. You try doing a mechanism with that, it's all kinds of craziness. So no, don't worry, don't need the mechanism. And by the way, yes, they have asked you to draw that in the past. They asked you actually to do a dot and cross for it. Can you believe it? I kid you not. They asked you to do a dot and cross for that. If I'm tempted to ask you to do it. Oh, go on then, guys. Give me the dot and cross for that. Pause the video. Give me the dot and cross. What a nightmare. They gave you that picture. They gave you the picture and asked you to translate it to a dot and cross. So it wasn't as hard as people thought. So I'll zoom out because I don't really. I wanted to keep it there to make it. Change in which direction won't matter. They're just looking for the numbers to be correct. Another dot and cross. There we go. And then these two options are a bit more tricky. Got a single bond there, a single bond here. These two have got their two lone pairs there, but then they've gained an electron, which is what makes them fully negative. Remember, they're the negative ions, and those electrons there, those crosses, have been gained from the sodium atom. When that molecule reacts with the sodium metal, the sodium loses its electron, becoming Ne+, and that therefore becomes minus. So I'll try and get rid of that as best I can. Don't need that anymore. So there's the dot and cross for it. Clever picture. If you don't like the charges being on their locations, you could alternatively do this, 2-. But I just think it's better understanding to show you where the charge is coming from. And those are those two electrons here. That's where the 2- is coming from. Students often then, of course, question chromium. Chromium's in a very odd position here, folks, because it's got 12 electrons in its outer shell. That actually explains the +6 oxidation state. Students often ask me, how do you know how many bonds something's making? It's a very difficult question. But in this case, the chromium is in a +6, which tells me that the number of bonds it's making is 6. It's quite a nice way of doing it, that. It's just hints and tips to being able to translate from oxidation states to dot and cross. Anyway, going back to my notes. So no, you do not. Chat disconnected. Please wait while we reconnect you. Unable to connect to chat, please try again later. Ooh. Chat's been disconnected. Ooh. I don't know how to fix that, folks. My chat has been disconnected for some reason. Don't know why. I'm trying to, all messages of the top. I don't know. Successfully connected. It seems to have reconnected me, folks. Will the option at the top not be dative? No, it won't be dative, actually, Tenzi. Good question. No, they're not. Oxygen wants to make 2 bonds. It gains an electron from the sodium in order, so it only needs to make 1 bond, a bit like sodium hydroxide. The hydroxide ion, the oxygen makes a standard bond and then gains the electron from the sodium ion. Good idea, but no. Okay, so at this point, we've done the equations for secondaries and we've mentioned that tertiaries don't do it. Right, okay, so now what we need to do is, now that we've got to that stage, we now need to talk about how we actually get this to happen. Because we now realize that we need to talk about practical methods. Yeah, this is now on to practicals. So if I had a primary alcohol such as ethanol, so we can now do practical. And guys, this is nice one. And that's exactly what I was, by the way. Practical. Now, you should have done this as a core practical, and we were going to be doing this, but since we're now on e-learning, I'm only going to be able to talk you through this theoretically, but what I will do is go into school and do it practically and videotape it and post it on the classroom, and I'll talk you through it with exam questions. So in terms of practical wise, here's how you do this. Because we know that primary alks go through a 2-step oxidation to an aldehyde and then onto a ketone. So there's a problem here because ketone, carboxylic acid. Darn. Sorry, folks, carboxylic acid. So how would we actually get each of these individual products? I want them separate. So how would I do it? Well, the first thing I need to do is I need to have a liquid alcohol. So this is my ol. I need to be able to add to it K2Cr2O7 and dilute sulfuric acid, dilute H2S4, and then I need to heat this. So there's a problem with that, folks. Yeah, the problem is heating anything. You always need to know to bene, heat is always needed. We know this. Heat is always needed. Heat required. Heat needed. The reason why the heat is needed is you've got to break, this is organics. Organic is covalent bonds. And we've got to break covalent bonds. They're strong. You've got to provide heat here, folks. You've got to provide the heat. Got to provide the heat to break those. Right. The problem is heating is dangerous. Heat organics is a problem. It looks like I put organics. Heat organics is dangerous. Hazard. The reason being is all organics. Oh, I don't know why my pen is fluctuating a little bit. It might be that I think my pen may be dying. I can always replace the battery on it. I might do that in a minute. The hazards are organics are flammable. We know this. Oh, my pen is hiccuping. I'm just going to replace the pen, folks. You can pause the channel, see if I can find an alternative battery. That's frustrating. Never need to do that. Hopefully one of them will be charged. We will see. So organics are flammable. And of course, that just simply means that if you were to heat this on an open flame, then you're going to be causing right problems. You could be potentially opening yourself up to fires, which is definitely not what we need. So these are flammable. Oh, my laptop is really, I don't know what's going on here, folks. My pen is really struggling, and I don't quite know why. Look, it just seems to be hiccuping. This might cause me a problem today. Ooh. I don't know what's going on here, folks. I do apologize. Don't really know what to do here, folks. Having a minor issue with my tablet. I'm tempted to take that up to that and see if it makes any difference. No, I think it is my pen. Oh. Sorry, folks, I do apologize about this. Do you know what I'm going to do is I'm going to come back to this since I'm just having a slight issue with my pen and I'm pretty sure it's just the battery and I haven't charged it. So I'm going to go and have a look at some exam style questions and talk you through them. So explain what is meant. I'm going to try and actually, maybe my laptop is struggling. No, maybe my laptop is struggling in terms of performance wise. Let's see if I can get rid of all of these things. Maybe it's just a performance issue. Let's see if I can get rid of all of these things. Let's get rid of that one and that one and that one and that one. Okay, we'll do it like this and see if that makes any difference. There we go. So let's try that. So these are just questions in terms of alcohols. We haven't got onto fermentation just yet. But what I want to do is I want to focus on this idea of looking at the structures and how these oxidation reactions appear in questions. So ethanol can be oxidized to an aldehyde or a carboxylic acid. Draw the structure of the aldehyde and carboxylic acid. You guys are now capable of doing this. Notice that they've given you a particular one and they've kept it standard. They haven't pushed you here. They haven't given you propanol. They haven't given you butanol or propan-1-ol or butan-1-ol. They're keeping it easy. So there's good. This is the nice lower level question, has links to GCSE. You can, if I just write a little bit, I don't know quite what my pen or my laptop is doing. I've never had this issue before. It's a bit of a problem. It just seems to be that my pen is having problems. I honestly don't know what's, it just seems to be flickering on and off. But you can do those now, folks. I can probably do it if I do it really slowly. I feel like it's my pen that's causing my issue. There we go. There's my aldehyde. I feel like I don't know what's going on. It's really frustrating. This is a new problem for me. There's your aldehyde, H's of course. Carboxylic acid. Give a suitable reagent and reagent conditions for the oxidation of ethanol to right. So this is now to do with the practical setup. Because we realize that primary alcohols can do this two-step process. What that means is we need to be able to consider where's the practical setup at the top, right? As I said, I don't know what's going on. I might even be able to check on what my pen is charged for, what my pen is charged at. Maybe I'll come back to this. Will the option at the top not be? Okay, it's still on terms of the same question. Right. What I'm actually going to do, folks, I'm going to actually pause today's lesson at this point. I'm going to end it now. I'm going to post these questions onto the classroom, and you can then have a go at doing them. And I will pick this up. I don't know when our next lesson is, but I will pick up exactly where I'm leaving off now. Our next lesson is Monday. I'll pick this up on Monday. So I'll end our lesson here, purely because I'm having technical issues, and we'll pick this up. I don't know quite why. But okay, folks, so I'm going to end it there. Let's see if I can get back to my original screen. Where am I? I'm up here. StreamYard. And go back to... else. Stop sharing. There we go. Right, guys, I'm going to end it there today. And I will come back to this next lesson on Monday. I might do one over the weekend if I can. But I hope it was useful. And as I said, I'll pick up the practical bit next time. Have a look at the questions that I'll post on the classroom, and that should hopefully be able to solidify some of this. All right, guys, I will leave you be. All right, bye, guys.